Now from Newton's law of gravitation, we got this relationship, that is F equals to G m1 m2 divided by d square, in which F is the gravitational force, G is the universal gravitational constant, m1 and m2 are the masses of two bodies, and d is the distance between the two bodies. Okay, now this value of G, this G is constant everywhere, and it is known as the universal constant because the value of G is same everywhere. Okay, so what is the value of G is 6.67 in 10 to the power of minus 11 Newton meter square per kilogram square. Okay, and other one is there, that is the Newton's law of gravitation is also known as the inverse square law. They are also known as the inverse square law because the gravitational force is inversely, the magnitude of gravitational force is inversely proportional to the square of the distance. That means magnitude of gravitational force means the size. The size of the force can be more or less depending upon the distance of separation between the two bodies. As already I have told you that body A and body B are there. They have been separated at a distance d. Okay, and body A can pull a body B. Okay, towards A it can pull, or body B can pull body A towards B. Okay, so that means now when you increase the separation, or when you increase the distance, the gravitational force will become less. Okay, that means more the distance between the two bodies, lesser will be the gravitational force. Similarly, when you decrease the distance, or when you bring the two bodies very closer to each other, the force of gravitation increases. So that is why the force of gravitation is inversely proportional to the square of the distance between each other, between the two bodies. Okay, so now, so why Newton's law of gravitation is known as the inverse square law is that because the gravitational force is inversely proportional to the square of the distance. Okay, now let us come to the how the distance will increase or decrease. Let us come to that point. Okay, now you know that F equals to 1 upon d square. Make this as equation 3. Okay, because equation 1 already we have made it here. F is proportional to m1 and m2. We have made this equation 1, which you have done it earlier. Then again F is inversely proportional to 1 upon d square, that is equation 2. Now F equals to 1 upon d square, make this as equation 3. Now take that d. Okay, now let the d will be, the value of d will be doubled. Okay, so let us consider the value of d will be doubled. So what I can do is that, now if the value of d, that means the distance can be doubled. Now if the distance can be doubled here, so what I can write here, f dash equals to 1 upon 2d whole square. That means distance I have doubled in here. Okay, more the distance. So force I have written here, f dash equals to 1 upon 2d whole square. Now f dash equals to 1 upon 2 square means 4d whole square. Make this as equation 4. Okay, now dividing equation 4 by equation 3. So what we can get is that when you divide it, now equation 4 I write it here, f dash equals to 1 upon d square divided by sorry, f dash equals to 1 upon 4d whole square divided by f upon 1 upon d square. Okay, so f equals to 1 upon equation 4, f dash equals to 1 upon 4d whole square divided by f upon 1 upon d square, taking this value. Okay, now what I can do is that f dash, okay, now f dash what I can do is that, now you divide it here. When you divide it, what will happen here? 1 upon 4d whole square into this d square will go up divided by 1. Okay, so this d square and d square cancels, so equals to 1 by 4. Okay, so what will come is that f dash will become 1 by 4. That means when the distance is doubled, the force, the gravitational force will become 1 by 4 times. It will become 1 by 4 times. Okay, so this is the value, look at it. 1 by 4 times means the value of F. Since we have considered F equals to 1 upon D square, then making it as equation 3, then F dash equals to 1 upon, F dash equals to 1 upon 2D whole square, F dash equals to 1 upon 2 whole square means 4, then D square remain as it is, D square, dividing, and dividing you will get the value, that is the gravitational force, as 1 by 4 times. That means if the distance get doubled, the force of attraction will become 1 by 4 times. Similarly, if the distance will become half, half means you reduce the distance. Okay, so when the distance will become half, when the distance equals to half, then the force of attraction will become 4 times. That means it becomes more. Okay, similarly, when the distance will become 1 by 6, that means if the distance become, you can take 6 times it. If the distance you take it as 6 times, then the force of attraction will become 1 by 36 times. Similarly, okay, so look at it. So D equals to, if I take that distance equals to half, first I have made the distance doubled here. Doubled means 4D whole square. Okay, now I am making the distance half. If I make the distance half, then the force of attraction will become 4 times. It becomes more, doubled. Okay, 4 times. Similarly, the distance will become 6 times here. Okay, then the force of attraction will become 1 by 36 times. Similarly, if the distance will become 1 by 6 times, okay, then the force of attraction will become 36 times. So that means when you go on separating the distance, or when you increase the distance, the force of attraction will become less, and when you decrease the distance, when the distance between the two bodies becomes closer and closer, the force of attraction will become more. Okay, so because of that condition, this Newton's law of gravitation, we call it as a inverse square law. Okay, now the next point. Now the next point will come to application, that is the uses of. What is the use of Newton's law of gravitation? So Newton's law of gravitation, on what purpose the Newton's law of gravitation is useful? So number one, it is used to find the value of z. Number one is, it is used to find the value of z, means small letter z, that is acceleration due to gravity. Newton's law of gravitation is very useful to find the value of acceleration due to gravity. Newton's law of gravitation is also useful to find the value of gravitational constant. It is also useful to find the masses of planets and the stars. It is also useful to find the radius of the Earth. So these are the application of Newton's law of gravitation. Now the next one will come to, the next point will come to the unit of gravitational constant. As we know, the value of gravitational constant is 6.67 into 10 to the power of 11 Newton meter square per kilogram square. Okay, now how that Newton meter square per kilogram square, how that value comes? Okay, so you don't have to mug up, you just remember the process, how it has been calculated or it has been done here. So we know that force equals to G m1 m2 divided by d square. Consider at the denominator 1 here, cross multiplied here, G m1 m2 equals to fd square. Okay, multiply this. Now G equals to fd square divided by m1 m2. Now, what is the value of SI unit? What is the SI unit of force? Newton. I can write calculator M. SI unit distance, meter. So distance, two distances are there, distance square. So I write it here, meter square, divided by SI unit of mass, kilogram. So the two masses are there. So kilogram square. Now what I can write here? G equals to Newton meter square per kilogram square. So this is the unit. This is the SI unit of gravitational constant. So SI unit gravitational constant is Newton meter square per kilogram square. Okay. Similarly, in the value of gravitational constant. Okay. In CGS unit, I can write here the CGS unit of force is dyne. Okay, the CGS unit of distance is centimeter. I can write it as centimeter square. And the CGS unit of mass is gram square. So 9 centimeter square per gram square is the CGS unit of gravitational constant. Is it clear? Now this value of G, since it remains constant here, and the value of G does not depend, the value of G, that is gravitational constant, does not depend upon the masses, it does not depend upon the mass, as well as it does not depend upon the distance. Okay, the value of gravitational constant does not depend upon the distance, neither depends upon the distance nor depends upon the mass. That means the value of gravitational constant is equals to force. That means G equals to F, I can write here, though they do not depend upon the distance and the mass. So how it comes is that G equals to F, I'll write it here. Let the distance between the two bodies will be 1 meter. Okay, so 1 square, and the masses of two bodies, I'll take it as 1 kilogram each. Okay, so G equals to 1 square means 1, F into 1 will be 1 divided by 1 will be 1, so I can write it F equals to G. That means G equals to F. So that is gravitational constant is equals to gravitational force. So therefore we can say that gravitational constant does not depend upon the masses of the body. Either it can be a more mass or smaller mass, does not depend, and also does not depend upon the distance between the two bodies. So since the value of gravitational constant, it is this value is remaining constant, it is a universal constant, since the value remains same, so therefore it does not depend upon the mass of the body and the distance. Okay, now the next one is the importance of universal law of gravitation. First one I've told you about the uses. Okay, now we'll come to the importance. Now what is the importance? These universal gravitational constant, universal law of gravitation are useful or responsible in the formation of tides. Okay, high tides and the low tides. Okay, formation of tides. It is also responsible for the flow of rivers. Okay, and also the rainfall and the snowfall on the earth. Okay, likewise, they are also responsible for the motion of the moon around the earth. So these are the importance of the universal law of gravitation. 6.67 into 6 multiplied. 6.67 into 6. 6 sevens are 42. 6 is 36. 37, 38, 39, 40. 0, 4 will remain here. 36, 40. 1 to decimal place. That is what will come here? 40.02 into 10 to the power of minus 11. Okay, plus 24. Now why I am writing this? Exponent formula. Mathematics. 10 to the power a to the power n into a to the power n equals to a to the power n plus n formula. A to the power n into a to the power n equals to a to the power n plus n. This is the formula you are using it. So that is why 10 to the power minus 11, nothing is there, you have to consider plus 24. Okay, divided by, now 6.4 whole square means 6.4 into 6.4. 4 4s are 16. 4 6 are 24. 25. 6 4s are 24. 6 is 36. 37, 38. Okay, then 6 5 plus 4 9. 8 9 10 4. That means 1 to decimal place. That is 40.96 into 10 to the power 6. A to the power n into n will be a to the power n. Multiply that. So 10 to the power 16 is 12. Okay. Now 40.02 into 10 to the power of, subtract this here, 4 minus 1 will be 3, 2 minus 1 will be 1 equals to 30, divided by 40.96 into 10 to the power of 12. Okay, now what will happen? This 10 to the power 12 and this cancels. 10 to the power 13 means it cancels to 12 and 10 will cancel, only 1 will remain here. Okay, so in the next line, what we can do is that, now remove the decimal here. 4002 into 10. 100 will go up, into this 10 will come here, divided by, again, this 496 will come here into 2 zeros will, that is 100 will come. Look at here. 4002 into this 100, that means I am cancelling this 100 will go up here, 100 into this 110 will come here. Divided by 4096 into, after decimal, that means you have removed the decimal, 100 will come, this cancels here. Therefore, now what you can do is that 40020 divided by 4096. When you divide it, then the value will come as 9.8 meter per second square. Is it clear? Now, this is the value. This way you can find the value of acceleration due to gravity. Now, the next point. There are certain formulas are here. Okay, as we know, the motion in one dimension. We have done that before. Okay, motion in one dimension. Three formulas are there. One formula is v equals to u plus at. Then second formula is there, v square equals to u square plus 2as. Okay. Third formula is there, s equals to ut plus half at square. These are the three formulas. So considering these three formulas here. Okay. But here in this gravitation, in this chapter, instead of a you will use it g, acceleration due to gravity. Instead of s you will use it h. Only the difference is that. But other will remain same. V will remain same. Final velocity, initial velocity. Instead of acceleration, you write it the acceleration due to gravity. Then t will be time. Here also same. Okay. And instead of s, you write it h. Okay. Now how this relation can become minus here. This all the formulas I have written in between the two alphabet, between the two terms, plus sign is there. Okay. Now it can become negative. When it becomes negative is that when this equation will become negative when a body is thrown vertically upward. Okay. When a body is thrown vertically upward, then v equals to u minus gt. Okay. Similarly, v square equals to u square minus 2gh. Then instead of h, I can write here h equals to ut minus half gt square. Okay, now this equation you will apply. The equation will change. The minus sign will come when a body is thrown vertically upward. But when a body is thrown vertically downwards, then the relation will become again positive here. When the body is thrown downwards, because acceleration is produced, you know that. Okay, so in that case, this relation or this formula will become positive. That means v equals to u plus gt, v square equals to u square plus 2gh, then x equals to ut plus half gt square. So this condition will happen when a body is thrown vertically downwards. When the body is thrown vertically upwards, then the formula will become negative. Then this equation of motion, this formula we call it as an equation of motion. Okay, so it becomes negative. Is it clear? So these are the things, okay, you should understand in this chapter, gravitation. Thank you very much.